Hello, this is Taegyun Kim. Today I'm gonna talk about the problem 8 from Exam2. So in this problem, we were given two different conductivity, which is 0.1 and 0.2. However, the potential is the same as 100 volts, and the cross-section of the resistor is 4 millisquared. So for this problem, we know that the electric field will not be different, so that we can say EA, which is electric field of material A, and EB will be equal. And we know that the current density is directly proportional to the electric field. But before, we're gonna calculate the electric field, which is equal to the potential difference over the length. These are both given in the problem, which is 100 volts divided by 10 meter. And we can say that this is 10 AX V over M. Since we have to calculate the current, since we need to get the resistor of this object, it will be easier to calculate the current for this object. Before that, we are going to use the current density equation, which is J equal to I, which is current, over the area A. However, by the Ohm's law, which is V equal to IR. Since we are only given the conductivity in this problem, we will utilize this equation to get the current, and then divide that within the voltage to get the resistance. So using the Ohm's law and utilizing the current density equation, we can say that J is equal to V over RA. We can also say that this is equal to electric field times L over RA. So this equation is actually from this equation. And using the R equal to rho L over A, we can conclude that rho is equal to RA over length. Then we can conclude that J, current density, is equal to electric field divided by rho. And this rho is actually 1 over rho in this equation. And this 1 over rho is equal to the conductivity. Therefore, we can say it is equal to rho times E. Now we can easily solve the problem utilizing these equations. So we said that J is equal to the conductivity times electric field. And the conductivity is different for each material, so I'm gonna say this is JA. So JA equals 0.1 times the electric field, which is 10. This is equal to 1 AX area over M squared. Same as for material B. This is equal to 0.2 times 10 AX V over M, and this is equal to 2. Since the current will be the same throughout this object, we can simply say this I is equal to JA times the area of each material, which is just gonna be 2m squared. This 2m squared is coming from this area at the side. This area at the side, which is 2 times 1, so it's 2m squared. Plus JB, it also has the same area under here, so 2m squared. This is equal to 1 times 2 plus 2 times 2, which is 6. Now we can simply get the resistance by using the Ohm's law. Using the Ohm's law, resistance equal to V over I. And V is given in the problem, which is 100 volts, divided by the 6 amps that we got. This is equal to 16.7 ohm.